Okay, so yeah, today we're going to be going over the Sudoku solver backtracking algorithm, and I'm going to be walking you through an example of how it would be used visually, and hopefully that'll help you all in the process of actually programming it. So there's actually two ways, or at least two main ways you can solve this Sudoku board, and the first way is probably the way that most of you might try going about this, and I'm just going to call it the naive algorithm. And essentially what this does is it's going to go row by row, column by column, and it's just going to try 1, it's going to try 2, it's going to try 3, 4, 9, and it's going to do that for every single cell throughout the entire puzzle, basically coming up with every single possible board configuration there is until it gets the proper board configuration that doesn't break any of the rules. Now you could do it this way, but depending on how difficult the board is to solve, there could be millions of different, actually there could be way more than millions of different configurations. I don't know the exact math, but I want to say it's at least in the billions. I want to say it's 9 to the 81th power possible configurations. Don't quote me on that. But I think that's the proper math, maybe. Anyways, we don't want to solve this Sudoku board using the naive algorithm. What we want to do is we want to use the second way, which is going to be called the backtracking algorithm. And this is how you should approach this problem. So the first thing we want to do in this backtracking algorithm is, let me actually pick a different color. Oh, what color should I? I'll just use black. Okay, so the first thing you want to do is you want to find an empty box. So find an empty box, right? And the way we're going to find empty boxes, we want to go row by row. So we want to scan through the first row until we find an open box. Well, clearly it's going to be this one. So we would return the coordinates here. I'll even write it. So this is 0, 1, 2, 3, 4, 5, 6, 7, and 8th index. And then for these ones, let me get these two. So we would return the position of 0, 2, right? So we would return 0, 2 as our position for our open box. Delete this. Okay, so once we find our empty box, what we want to do is we want to try all possible numbers. Try all numbers. Now I know this sounds like we're doing it the naive way, but eventually when we run into a row configuration that doesn't work, we're going to be inserting this backtracking algorithm, and we'll get there. And then I'm also going to walk through an example with you all so you can see exactly how it actually works in the back. Okay, so find an empty box, then you try all numbers, then you validate you validate your position, your number. Let me change the color. So validate it. So what I mean by validate is you're going to validate the row, the column, and in this case the 3 by 3 box that you're currently in. So for example, if we were to insert 4 here, we would run through. First we would check, okay, does this follow the row rule? And it wouldn't, because there's a 4 on this row right here, right next to it, so that wouldn't work. So we wouldn't be able to use a 4. We would try a different number. Let's say we tried a 5. Okay, 5 works for the row. So oops, that looks horrible. So 5 works for the row, it works for the column, and it works for the box. So 5 could potentially be a spot. Let me just back out of here. And then, okay, so once we validate it, then we want to essentially repeat this process until we run into a configuration that doesn't work anymore. And when we get to that, once we get there, we are going to start backtracking. So let's go ahead and actually just work through a problem, work through this board and see how that would look. So first thing, find an empty box. Okay, so we got this one. So now I have to try all numbers. So I'm gonna try 1. Okay, validate that. Nope, there's a 1 right here. So I can't use that one. Okay, let's try 2. 2 works on the row, works on the column, works on the box. Okay, good to go. Now we repeat. Okay, find an empty box. So we'll use this one. And then we'll try 1. Whoa, nope, 1 doesn't work. 2 doesn't work. It is 3, and then 4 doesn't work either. And then I believe 5 does. So 5 works on the row, works on the column, and it works on the box. Cool. So now we have 9, 4, 2, 5, and then 3, 1. So our next empty box will be this one right here. So we'll try 1. Again, that doesn't work because we already have a 1 in our row. We'll try 2, 3, 4, 5, and eventually we'll get to 6. 6 works on the row, on the column, and in the box. So we'll put 6 right here. And then we'll get to our last empty box in the row. And we'll try 1, nope, 3, 4, 5, all the way up to 8. And then we'll validate this. Well, it works in the row. It works in the box, but it does not work in the column. So since we're out of numbers to try out, we actually have to start backtracking now. So instead of 8, or instead of trying to figure out what goes here, we have to backtrack, go back 1, and we'll try 7 right here instead. So instead of 6, we'll try 7. Oh, 7 doesn't work because we have a 7 right there. So let's try another number. Let's try 8. Well, 8 doesn't work because we have an 8 on the column. So we can't use 8. And then we'll try 9, but nope, 9 doesn't work because we have a 9 in the box. So we are going to, let me erase this. We are going to backtrack once again. So instead of putting a 1 here, oh wait, nope, that 1 was already, that was a part of the puzzle. Okay, so we'll backtrack all the way to this one right here. And instead of a 5, we will try to use a 6. Does the 6 work? Well, it works for the row, works for the column, and the box. Cool. So now we'll go back to this one right here. So then we'll go 1, nope, 2, 3, 4, and 5, nope, 6, nope, 7, nope, 8, nope. Well, that doesn't work, so we have to backtrack again. So we'll change the 6 to a 7. Oh, 7 doesn't work. 8. Yep. So we'll turn that one into an 8. And then we'll move on to finding our next empty box. And we'll try 1, nope, 2, nope, 3, nope, 4, nope, 5, nope, because we have a 5 right here. 6, I believe 6 does work. So we'll put a 6 here, and then we'll move on to our next open box, which is this one. So we'll try 1, nope, 2, 3, 4, 5, and I believe 5 does work. Yep. So 5 works. This is now our last open box, so we will validate. Okay, it works in the row, it works in the column, and it works in the box. So boom, we got this first row completely filled. Now what we'll do is we'll go on to the second row right here. So yeah, in terms of index, it'd be the number 1. And then we'll just repeat this process. We'll find the first empty box. Okay, let's try 1. Does a 1 work? Yep, I believe it does. Yep, cool. Next empty box, we'll try 1 here. 2, nope, 2 doesn't work because we have a 2 in the box. We'll try a 3. 3 does work, so we'll put that in there, and then so on and so forth. We'll just keep doing this until we eventually get to this very last cell in the bottom right of the box. And once we're able to validate, like, okay, we finally got, let's say it's a 6. Boom, we got our last number, it's a 6. The board is now completely solved because we've as we have filled out numbers throughout the box or throughout the Sudoku puzzle, we have been validating as we've been going, and we've been incrementally been filling out the Sudoku puzzle. So that's essentially the backtracking algorithm. Some notes on how to approach this. So what I would do, whoops, oh no, what I do. Let's see. Okay, yeah, so what I would do is I would break this problem up into functions, into multiple functions.